All right, we're looking at 1.2, which are limits. So we're going to look at them numerically and graphically. We're going to see when we don't have a limit, so when the limit does not exist. And then also learn how to write and say a limit. So a limit is the value of f of x or y as x approaches a certain number. The limit is written as the limit as x approaches c of f of x is equal to L, and that's written right here. Or we can say the limit as f of x as x approaches c of f of x, okay? So the limit is when we get really close to a certain x value, what's happening to our y value, okay? So we're going to look at our first example. So we say this, the limit as x approaches 1 of x cubed minus 1 over x minus 1. My table is a little off, so we're going to do as x approaches 1 from the left, and from the right. Okay, so from the right side and from the left side. I already went in and typed this into my calculator. So here's what I got. I'm only going to be graphing the first equation. Notice my equal sign is turned off for the second equation. So I'm going to go ahead and graph. And you can see my graph looks like a curved graph, right? And then I know that when I trace at x equals 1, my function is undefined because I'm dividing by x minus 1. So I know that my value here is undefined. I'm going to use my table, so second table, and I'm going to change my table set to ask instead of auto. We did this at the beginning of the year. Okay. And I'm going to go ahead and start at 0.75. And I get an output of 3.3125. So I'm going to go ahead and let's change this up a little. Okay. Let's see if we get both in there. All right. Next, so 2.3125. I'll go ahead and put in 0.9. We get 2.71. 0.99. 2.9701 and 0.999. Okay, so 2.997. Okay, so from the left, those are the values that I'm getting. Take a minute and look at what number do you think we're approaching. Okay. On the right, I already typed these into my calculator, so I'm going to start out with 3.8125. Then I get 3.31, then 3.0301, then 3.003. So when I look at my table, from the right, what value am I approaching? It looks like from the right, I'm getting to 3. And from the left, I am also approaching 3. So my answer is the limit as x approaches 1 of the function x cubed minus 1 over x minus 1 is equal to 3. So notice the function was undefined, but we are approaching 3. So the limit as we get close to x equals 1, or the output as we get close to x equals 1, is going towards 3. The actual output and the limit do not have to match. Okay. So the next one, we're going to look at this graphically. So if I look at the same function graphically, okay, at x equals 1 right here, from the left and from the right, what value are we approaching? Well, it looks like we're getting close to 3. Okay. This output right here, this output right here is getting close to 3. So we'd say the limit as x approaches 1 of x cubed minus 1 over x minus 1 is equal to 3. Now this limit operator is super important. Without it, we're actually saying the actual value. We're not looking for the actual value. We're looking for the value we get close to. Okay. So we're going to find the limit as x approaches 0 of the function. So I went ahead and typed this into my calculator. I'm going to go ahead and turn that one off. Press enter to turn that one on and graph. And I get a function that looks like this. So I get, I'm just going to use my trace function. When x equals 1, y is equal to 2.4. Oops. Okay, 2.4. When x is equal to 0, y is undefined. When x is equal to negative 1, y is 1. Okay. And I'm going to go ahead and get one more point. When x equals 2, y is 2.7, so a little bit higher. I can see at 0 it's undefined, and then it continues on its merry way. So graphically, this is what our function looks like. And then what I want to do is I'm going to find the limit as x approaches 0 of this f of x, and I'm lazy, so I'm going to write of f of x. Remember that refers back to this equation. Okay, equals, if I look at the graph, on the left, my graph is approaching a certain number, and on the right, so on the left, what is the y value getting close to? And on the right, what is that y value getting close to? Well, it looks like it's getting close to 2. Okay. On the next one, I'm going to go ahead and look at it on a table now. So go ahead and plug in values that are close to 0. I know at 0 it's undefined because I already plugged that in. Okay. So what I want to do is get values that are really close to 0. So like negative 0.1, negative 0.01, negative 0.001. So getting closer and closer to 0. On the right, we'll do the same, 0.1, 0.01, 0.001. Okay, so same but positive. And when I plug those into my calculator, I get 1.949, 1.995, 1.999. On the right, I get 2.049, 2.005, 2.004. So on the right, on the left, and from the right, what number are we getting closer and closer to? Looks like we're getting closer to 2. And that's good because these matchy-matchy. Okay, graphically and numerically, they should match. All right, so I think that this is our answer. Right here, the limit as x approaches 0 of f of x is equal to 2. Or you can say the limit as x approaches 0 of x over the square root of x plus 1 minus 1 is equal to 2. These are both acceptable. Okay. All right, so notice that even though f of 0 is undefined, the limit is equal to 2 because both sides approach the y value of 2. Okay? So it's not the actual value, it's just what we're tending towards. Okay? All right, next. This is really important right here. A limit exists if a function, or for a function, if the left and the right limits approach the same number. So if on the left side and the right side, the limits are the same, then so they're approaching the same number, then we have a limit. This is regardless of whether the limit is actually approaching that point. So f of 0 doesn't have to equal the limit. Okay. All right, so what we're going to do is look at this next one. And this is written a little weird. I think my computer freaked out. Okay, so f of x is equal to the function 1 when x does not equal 2. Okay, and it's equal to 0 when x is equal to 2. So right now, for everything except 2, the function is equal to 1. And then when x equals 2, the function is 0. Okay, so what I see is that right here, what does f of 2 equal? Oh, f of 2 is equal to 0. Okay, but now let's get the limit when x is equal to 2. So the limit as x equals to 2 is of f of x. So we have to look on the left. So what is happening as we move left? Well, it looks like it's approaching 1. And if I move from the right, the graph is also approaching the value 1. So the limit is 1. No matchy-matchy. It's okay. Okay, so the limit value does not have to equal the actual value of the graph. Okay, now, when does the limit not exist? The limit does not exist when the left and the right limits are different. So here's a function. This is the function absolute value of x over x. Okay, so when x approaches 0, that's right, when x approaches 0, what is happening? Okay, on the left, it looks like we're approaching -1. And on the right, we're approaching 1. Matchy-matchy? Okay, the left and the right have to match. So no matchy-matchy, left and right. So the limit does not exist. The left and the right do not match. I know, no matchy-matchy. Okay? So next, here's another example of when the limit does not exist, is when the limit is unbounded. So a limit has to go to a finite number. So when it goes to infinity, guess what? No existy. Okay? So when x goes to 0, so again, right here, on the left, the graph is going towards infinity, right? On the right, the graph is going towards, it's going up, so it's going towards infinity. That's unbounded, so the limit does not exist. Okay? So the limit has to be a finite number. So not infinity. Okay? And it has to matchy-matchy. The next one, as x goes to 0, all right, on the left, the x is going down, so towards negative infinity, and up on the right to infinity. Okay, this is like double no. No matchy-matchy. No matchy. On left and right. And it's unbounded. So the limit does not exist. Okay, this is a fun one. The limit does not exist when you have oscillating behavior. So like that, oscillating, goes back and forth. Okay, so it jumps back and forth. Okay, So this one jumps back and forth between like 1 and -1, so sine of 1 over x, as x approaches 0. So here, it's just jumping back and forth and back and forth and back and forth. So the limit does not exist. There is an exception, and that's when the oscillation, so it's okay if the oscillation is getting smaller or closer to 0. So in this case, the limit as x approaches 0 of x sine 1 over x, this actually oscillates back and forth, but you can see that the values are getting closer and closer to 0. So we actually get a limit of 0 here. And that's our first limit video. It's all about the matchy-matchy, y'all.